Hello, everyone, and welcome to our new episode on Cloud Launch and Learn. Today we have Nikos, our guest speaker from Sweden. So, hey, son, they're in
Hey,
Sweden. and
hello,
yeah,
everybody.
let's put some sunshine to Sweden so everybody feel warm and excited. And all over the world, everybody feels that happiness. And thank you again joining everyone to our studio. Nikos is actually a well-versed professional in Microsoft and Azure technologies. In today's session, he is going to demonstrate us the Azure Service Bus and event-driven, development and messaging. How you can use these technologies and Azure Service Bus to basically, get your problem solved. And in addition to that, he would also show the awesome integration that comes with that you can use with your Azure services. So, Nikos, welcome. Do you want to say a couple of words here before we switch to the slides?
Thanks a lot. Yes, absolutely. I'm very happy to be here. This is the first session I do for Cloud Launch and Learn. I try to be very active in communities, and I'm very passionate about Azure and Microsoft technologies. I was very happy to discover this community, and I see that you do very, very interesting sessions weekly, and most of them are in quite suitable hours for most of us. It's not easy to make a session suitable for pretty much the whole world. But I think this time works quite okay, at least for the United States and the most part of Europe. I think we can have many people, and it's a very nice thing. I'm very happy to be here.
Thank you, Nikos. Thank you for those words. And here at Cloud Launch and Learn, we are really, happy to welcome you and your session. And
Thank you.
here I switched the screens here to show this, initial slide that Nikos is going to kick off his presentation with. Meanwhile, if you have any questions, put them in the chat. I'm going to monitor them and we'll bring them to the studio and get them addressed. So, Nikos, please go ahead.
Thanks a lot, Erhan. Okay, so once again, thanks everybody for joining. I'm very happy to be here, and let's get started. Today, we are going to talk about the Azure Service Bus, which, spoiler alert, is not a bus, it's a message broker, but more about that in a minute. First of all, a few words about myself. My name is Nikos Delis. I work as a senior cloud engineer and cloud evangelist at Halo. I am very passionate about Microsoft Azure and yeah, pretty much all of Microsoft technologies and frameworks. I have a few certifications that help me demonstrate my skills, and I also do have a blog called ND Technique, as you see it in the slide, .com. I do a podcast called Azure Triumphs, stories of people who succeed with Azure. You can find it on Spotify, Google, and Apple Podcasts. And I do try to be as active as I can in communities. And that's why I'm very happy once again to be here. Now, the agenda. Because as you know, no agenda, no attenda. So let's see what we have today. First of all, a short introduction of Service Bus. What is it and why do we have it? How do we use it? Then I know that the topic that gets a lot of discussion is the differences between the Service Bus, the Event Grid, and the Event Hub, which all are products of the same family in Azure. I am going to give you a few examples of how you can use Service Bus as part of your architecture. We are going to talk about the first in, first out paradigm and how it can be implemented in the Service Bus. We are also going to talk about the scheduled deliveries of messages, what the data letter queue is, and last but not least, I will try to present you some best practices and a few pitfalls to avoid when using the Azure Service Bus. So let's get to the 101 of the Azure Service Bus. I hope you can excuse the barking. I am at home and we do have a dog, so sorry for that. So the Azure Service Bus is one of the oldest Azure resources. It has been over 10 years in Drift. If I'm not mistaken, Azure was launched 2008 or something. So it came up pretty early, and it has been live since then. And over all those years, they have only lost 7 messages. Can you imagine how many millions, billions, trillions of messages they have processed and they have delivered successfully, and they only have missed 7? It's amazing. It's one of the most trustworthy services if you ask me, for all cloud service providers. Then the definition of service bus taken from Microsoft Learn is that the service bus is a fully managed enterprise message broker with message queues and publish subscribed topics in a namespace. The service bus is used to decouple applications and services from each other, and a lot of other things. And this is a good point to make the division between a queue and a topic. And I think that the image I have here in this slide depicts the difference quite effectively. The queue is guarantees a simple one sender, one receiver communication, while the topic has one sender but may have multiple receivers. So a topic needs subscriptions, and each message gets delivered to each subscription. So each receiver will get the same message, unless they filter it out, or if they, for some other reasons, do not receive it. But the important thing to keep here is that the message gets delivered to each receiver. And this is important to remember, because I have been asked the question, what happens if one receiver processes the message first? Does it disappear from the others? No, it does not. Every subscription is going to get a message. Of course, there are some limits and quotas. Before getting to them, let me just mention that we have 3 tiers for the Azure Service Bus. We have the basic one, we have the standard, and we have the premium. And they differ quite a lot in the features that they support, in their performance, and of course in their price as well. So there is the basic tier, which is the consumption tier, let's call it like that, which has very few features. Actually, it has only the pretty basic features. You can only send and receive messages, and there the messages can be up to 256 kilobytes, as in the standard tier. And in the premium tier, we have 100 megabytes. Then the queue or topic size can get up to 5 gigabytes for the standard tier and 80 gigabytes from the premium tier. Now you might wonder, why do we need to have a limit on the size? And of course, this is because it is in the nature of Service Bus to keep the messages only as long as they are not processed by the receiver. So the sender sends a message. Service Bus keeps it in the queue or in the topic, and when it has been processed by the receiver, then it is removed. So we only have a certain amount where we can save our messages, and then if this amount is full, if we don't have any more space, then the messages are not going to be delivered. We also have a limited number of messages per transaction, which is 100, both for synchronous and asynchronous sendings. And we also have a limit of how many topics or queues we can have per namespace. Namespace is the grouping of queues and topics in a service bus. So we could say that a a service bus is a namespace. This is actually what we create. We create namespaces when we create service buses. Carrying on with a one-on-one, we have the fact that Service Bus is one of the most popular resources because it is directly integrated with multiple other popular resources, such as the Event Grid, Logic Apps, Azure Functions, Power Platform, Dynamics 365, Azure Stream Analytics, which is a tool used for IoT. Also, the Service Bus SDK is polyglot. You can send messages using C Sharp, Java, C, C++, Python, PHP, Go, JavaScript, I believe even Rust, and you can even send messages using PowerShell, if I'm not mistaken. It is fully managed by Microsoft, and this is not something to ignore or to take for granted, because running a message broker is not an easy procedure. In order to create and deliver and sustain an industry-leading, reliable, and available message broker, you need to make sure that the messages are collected and delivered. You need to make sure that Service Bus is always available, and also the low the low I'm sorry, I'm stuck. Uh, the low time it takes for a message to be delivered, which is available in the premium tier, is also something that is not easy to do by yourself. So there are alternatives to Service Bus, such as the RabbitMQ or Kafka, can also be used for the same reasons. But Microsoft has its take on that, and it is a Service Bus, and they do promise industry-leading reliability and availability and great performance. And of course, again, from Microsoft Learn, Azure Service Bus is a fully managed enterprise message broker with message use and publish subscribe topics in a namespace. It is used to decouple applications and services from each other. And once again, I will show you what I mean with that later on. Now, regarding the differences between Service Bus, Event Hub, and Event Grid, I have to admit that when first taking a look on those three resources, one might be confused, and we might wonder, okay, but why do we need all those three? And if we do have a scenario where we need messages and message-based architecture, which one do we use? The truth is that it's not impossible to implement the same scenario using any of those, or both Service Bus and Event Hub, or even Event Grid in some cases. But there are some very discrete differences that make them apart. First of all, the Service Bus and the Event Hub use a push and pull model. This means that we have one sender that pushes a message, that sends a message, then the message has to stay in the Service Bus or in the Event Hub, and the receiver has to manually pick the message and do something with it. This is not the case in the Event Grid. The Event Grid is only does implement the push style distribution, which means that the Event Grid is responsible for delivering the message to the receiver, while in Service Bus and Event Hub, the resources are responsible for making the message available. They do not have any control, or they do not actually care about when the message is going to be delivered. And this is an important feature because it makes clear in which scenarios we can use one or the other. So we could generally say that the Service Bus is good for scenarios when we have a new task. We have a new task that needs to be done, and we do not really care when we are the sender, when it will be done. Even if it will be done, we just want to notify somebody about something. So the sender sends a message to the Service Bus, the receiver has to pull it, And we can do it by using queues and topics. And I remind that the queue is used for one sender, one receiver, while the topic can be used for one sender, multiple receivers. The event hub on the other side um, is not used for message-based communication. The event hub and the event grid are used for events, and we need to distinguish messages from events. In a way, one could say that a message is an event which contains data, while an event is just some information telling us that something has happened. And in such cases, where we need to stream a lot of events simultaneously when they have to be ingested by a service, then Event Hub is the way to go. Because in those cases, the sender can push messages and we can have millions of senders which send millions of messages, and then the receiver pulls them, or we can even process them as an aggregated entity. So let's say that we have a number of sensors sending events about temperature, and we need to know what the mean temperature is for the last hour. In that case, we maybe don't need to process each and every event that we have received, but we need to process them as a whole entity, as an aggregated result. So in that scenario, the Event Hub would be the best resource to use. Of course, Event Hub is designed to be partitioned and to process high volumes of messages. It has far larger limits than the service bus, and it is also best used for IoT project. We also have the Azure IoT Hub, which I don't I don't include in this presentation, but this is also based in the Event Hub. And last but not least, we have the Event Grid, which, as I mentioned, uses a totally different style. It uses the push style by getting messages from the sender to the receiver and making sure that what happened in the event is going to be processed and somehow managed by the receiver. I will continue with the architecture and how we can include Service Bus in our architecture. As I saw in this slide, what I have done here is that I have decoupled some workflows. So in this case, we would have a storage and an Azure function which triggers on a file being created in the Azure storage. Then it does something with that file and it calls another Azure function, which in its turn sends it later on to the Azure Data Factory. I also have an Azure Logic app, which needs somehow to communicate, to use an Azure function, to trigger an Azure function, to send data to an Azure function, which then will also push the data to the Azure Data Factory, or even it will create a file in the Azure storage. And last but not least, I have the API management resource here, which is not directly integrated to the service bus. But what we can do in this case is that we can create a message as a JSON object, put it in the body of an HTTP post request, and send it to the service bus using the API that the service bus exposes and makes available for us. And then now in this case, I use the service bus, but if I didn't have it, then I guess that the API management would directly use the Azure functions to either push data to the data factory or to create files in Azure storage. Now, what is the problem here if we didn't have the service bus, which I have in the middle? The problem would be that to make this workflow really work and flow, we have to have all the components up and running. If we don't have this one part of our workflow up and running, then none of it works. So if we did have a scenario when the Azure function has to tell something to the other Azure function, but it doesn't really care about the message being delivered on that very second, then we could use the Azure Service Bus as a middleman, as a middleware, if you prefer, to make sure that the message will be delivered and processed at least sometime. So by using the service bus in the middle here, we have decoupled, we have separated those functions from each other. So the service bus makes sure that the sender can send a message and the receiver, when it is up and running, when it is ready, when it is scheduled, when we do work for our business reasons to process the message, then and only then the message would be processed. This is, in my opinion, a great advantage because it allows us to guarantee uptime or at least functionality without having the need to keep everything alive and to keep everything running all the time. I use this architecture a lot and I have found it very useful, and I recommend even to you to use it a lot. Now, I have talked quite a lot, and I think that it is time for a demo. Let me see if I do not scan this yet. Let me see if I can move it here. Okay, I think it looks fine. So I have a research script here, and I think that it would be nice if I show you how we can create.
Nikos, hi.
Yes,
Just quick thing here. Thank you for coming to the demo. Can you make your screen a bit bigger so it's, if somebody is watching on a tablet or
what
on
about
a
now?
phone, it's much better. Thank you.
You're welcome. Okay, so let's see how we create a service bus. I am in my research group and I get to the marketplace and I will just look for the service bus. It is available right here. I will push create. Now I have my subscription, I have my research group. Let's call this Cloud Launch and Learn. Very good. It is available. I will put it close to me. And for the pricing tier, I will pick the standard one. Let's go to the advanced question. We will use the TLS 1.2, of course. Networking, yeah, let's make it public accessible. Don't worry, I will delete everything later. Tags, you have to use tags, but I won't. And now let's make sure that we can create this thing. It should not take that much time, but in the meanwhile, I will show you what I will do when this is ready. So when the service bus is ready, I will create a topic inside of it, and then I will create a subscription. Now, as you can see, it is already ongoing. It should be done in a minute. Then when even the topic is ready, I will take a key, a connection key, and I will put it in my other project here. Don't worry, Alhan, I will zoom in. I hope it is visible now.
Yes, it is. Thank you. And
Okay,
when you have a break on your demo, I'll bring some questions, but continue. Thank you.
absolutely, yes. And then I will put the link to the topic here in my settings. Let's see if it's done. It should be done any minute now. Let's refresh. Yeah, the namespace is done. So yeah, we're done. Let's go to the resource. So here we have the namespace. This is the service bus up to now, and as you can see, it's pretty empty. It has no queues, it has no topics. We cannot do pretty much anything with that, nothing with that right now. So let's go on and create a topic. Don't worry, I will explain the properties. I will call it SPT, service bus topic, and I will call this default. The topic size will be 1 gigabyte, and the message time to leave will be the default, which is 14 days. After 14 days, the message dies. I will explain later what dies means. And then we also have the enable auto delete on idle topic. So the message will be deleted if it is idle after the time that we configure here. I don't need that. Duplicate detection is also a very important feature because using message brokers, what we see is that most of them guarantee at least once delivery, but we might get multiple deliveries, and this is not always what we want. Actually, if that happens, then we have to somehow take care of it in the code. And also we could have partitioning, which I won't need for this demo. So let's go on and create a topic. It would only take a few seconds. Now I have it. Let's go inside it. Again, the topic by itself does not do a lot. We need a subscription to be able to see the messages that we get. And let's call that one default as well. The maximum number of deliveries for the subscription, I will put like 10. Yet again, pretty much the same properties here. Auto delete, I believe you can see, yeah, auto delete after idle for 14 days. This is the time to leave for the message, or we can also never delete it. And also we can forward the messages to another queue or another topic. And here we have the dead lettering options. I will talk about the dead letter queue in a minute after the demo. And we also have the message lock duration, and you might need to lock a message before processing it, mostly in cases where you need to get more messages before starting the process. Let's go and create a subscription. And now that we are done,
Quick
yes,
thing here,
Elha?
while you are creating the subscription, just take the
Mm,
pause. I would like to
yeah,
bring a question from Anand, okay?
yeah.
And he has a question regarding that architecture that you explained, that if
Mm,
receiver side application is not available for some time, right? It's down or
mm.
something happened. Does Event Hub holds the data to take until receiver consumes that message?
Yes, it is the same logic. It's again the push and pull style. So the message will be kept until its time to leave expires. And actually, there is no need for, or it's not a must for the receiver to pick it.
Hmm.
To be honest, I do not like the receiver name because we not really receive it; we pick a message. So I
Yes.
would call them pickers, and they might pick, of course. Like in most scenarios, I would like to pick it immediately, but we might have scheduled pickups, or we might take them when we have 100 of those. I don't know. It's a possibility we have.
And and in terms of configuration, right? Do you
Yeah,
remember or recall how long it can stay there if the pickers or receivers are down?
it is configurable.
Hmm.
This is the time to leave for a message. I'm not
Is there
aware if
like
there is
maximum
a
value or
max
so?
limit.
Yeah, something like that.
I am not sure, to be honest. Yeah, I will have to check it out because
All
I'm
right.
not sure. But
Well, it is
I
there.
think that it's, yeah, it is here.
Hmm.
It's that one,
All
and
right.
it's configurable. Yeah,
Thank you.
you're
Good.
welcome. Now let's carry on. So to send some messages to this topic, I have to create a key, and let's create a policy called let's call it send and listen, and I will be able to use it to send messages and to listen on messages. Let's create it, and I will take the primary connection string, and I to demonstrate the use of the service bus, I have created some Azure functions, the source code of which I will show you right away. But before that, let me put the connection string that I just borrowed here in the configuration of my Azure function. So let's edit this one and put that new one here. Okay. And also I have it down there, here as well. Now I will save And since I'm in the consumption tier of the function, it will take a couple of seconds before, let's see, I don't have any unsafe changes. So, but let's wait. Updating the web app settings, exactly. And in the meanwhile, I will put the same connection string in my local development environment. Let's put it here and also here. Very well. So now I can talk to the service bus from my machine, and I can also talk to it from Azure. Now this is done. So I will just check that the sender function is enabled and the receiver function is disabled. Very well. I will explain you why I did that. But in the meanwhile, let's get the app running. So now here on the command prompt, I will have my receiver, which is going to pick the messages. It is waiting for them to come. And I will show you again the QR code, which I hope you can scan. Let me make it visible. Very well. So all of you who are watching, you are very, very welcome to take your mobile phones and scan this QR code. Don't worry, it will normally get you to another function and offer you a nice message. I am also doing that from my mobile phone. Let's see what is happening. Yes, you see, we are getting a few messages. I believe that you recognize those funny names. So what is happening right now is that by reloading the web page, which you see, which is not a web page, it's just an Azure function expecting an HTTP trigger, you get a random funny name, which we put in a message and we send it to the service bus. And then my receiver here picks the message and puts it on the screen. So what I will do now is that I will close the receiver. Now I don't have a receiver anymore, but please do continue to send messages. I will leave it for like 5 seconds and then I will bring up Azure again to show you what is happening. Okay. So now I know that if everything went according to plan, then we should have a few messages available here. We have this topic and we have 24 messages available. This means that those messages have been successfully sent, but they have not been processed anymore. Now I can go to the Service Bus Explorer, which is a function that used to be on preview mode for quite a lot of time, but finally it's available, and we can do quite a lot of things with that. First of all, we have two modes. We have the peek mode, which allows me to see the content of a message if I do have the correct permissions, and but not mark it as processed, so it will not be removed by the subscription. Or we have the receive mode, and in this case, if I do receive the message, then I will do it. Of course, I will see it, but only once, so it will be deleted. I will leave it in peek mode, and I will take peek from start. So as you can see, I do have a number of messages here, and I can also see the text in the message body and a few properties. I did not mention it before, but you can have even custom properties in your messages. I will show you later when they can be used. And so now what is happening is that the sender is up and running. You can send as many messages as you want, or until we fill the 1 GB size of my subscription. And they will continue to arrive again and again and again until I run my receiver again. So the moment I run it, what will happen is that all the messages, now my receiver, which is an Azure function listening on that topic, is going to get all the messages and to process them and to present them here on our screen. So if I go back to the Explorer and refresh, you will see that I now have 0 available messages. So Once again, what happened was that while I had the receiver or the picker up and running, all the messages you sent were picked immediately. And the moment I closed it, nothing went down. You could still use the sender, you could still send messages, and they weren't lost. They were kept in my subscription until I was up and running again and until I was able to process them. I will just very, very soon show you the source code to that. So I have two functions here. I do have the sender function, which gets an HTTP trigger. It is the one you used. And I do have another function which responds to a service bus trigger. So it is listening on the connection which I took from the connection string earlier. It is only listening on this specific topic, and it is using the subscription which is called default. And inside of it, I have the queue item or the topic item, you name it. I also have some other properties, which I don't do anything with right now. But what I'm doing now is I take the queue item and I put it on the screen using the logger. The sender, which is the one you use to send your messages, is again an Azure function responding on an HTTP trigger. And what it does is that it gets a request. Then I use a name generator here, which I get from a NuGet package. I get a random funny name. Then I get the connection string from my variables, and I know the topic name, which I have hard coded here. I create a client to connect to the service bus. I create a sender to be able to send the message. Then I do create the message also, which I send asynchronously. Now, when this is done, I do create a response to send you back and to show you the name that you saw on your screens. And then it was the same name was printed on my console. I hope that you did understand what the use of Service Bus is and how it can be used to decouple application, because that's exactly what we did in this demo. I will carry on with a few important features. The first in and the first in first out pattern, and how it can be used in the service bus. Now I do have a QR code which you can scan to go to the documentation and get more information. But long story short, to implement the first in first out pattern, you have to use the sessions. So one thing I didn't talk about earlier is that each message can have custom properties, and one of those is the session ID. So if we do put the same session ID to multiple messages, then all those messages can be grouped by the session IDs. And in this way, we implement a first in, first out pattern, because as you can see here, all those messages are being sent in that order. And the orange ones have the same ID, and the blue ones have the same ID, and the purple has its own ID, and the greens have also the same ID. So if we put multiple IDs to them, then we will get the effect of first in, first out pattern. So to do this, we have to enable sessions, which is done on the queue or on the subscription level. We must set the session ID property in each message. And of course, we use it to implement scenarios such as the request response pattern. And just a short notice, the request response pattern is used to cover the case when the sender needs to know if the message has been processed. So in that case, we use another service bus from the opposite direction, where we can notify the sender that, okay, now the message has been processed. Now, keep in mind that there is one pitfall in this scenario, but I will come on that a little bit later. Another important feature of the service bus is the scheduled message deliveries. There are scenarios when the sender wants to decide when the message will be available for the receiver or for the picker. And to do it, it's very, very simple. We have two ways. The one is to set the schedule and queue time UTC property, or to pass both the message and the schedule time. I can very, 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 very fast show you. Here I do have the message, and if I put in this property daytime now, add hours 2, what will happen is that the messages sent in this way will become available for the receivers after 2 hours. Carry on. The dead letter queue. Yes, this is also a very important feature that Azure Service Bus implements. I mentioned earlier that we have the time to leave property for the messages. And what happens if this expired? Does the message just disappear? No, it doesn't. Service Bus may have queues, special queues, which are available for us on subscription level or on queue level. And those are used to save messages that for some reason must disappear from the description or from the queue. And some of those reasons could be that the header size has been exceeded, that the message, as I mentioned earlier, we have a limit on how big the message can be. So if it is over 256 kilobytes in the standard tier, then it will be moved to the DLQ. The time to leave property may expire. If we have configured the subscription as a session ID demanding one, then a message which lacks a session ID will be moved to the dead letter queue. And of course, you saw also earlier when I created the topic that we could pick forwarding options, like to send the messages to other queues or other topics. And those forwardings are called hops. And we have a maximum number of those which can be done. And of course, this is configurable. And after that, the message is moved to the dead letter queue. Now, why would that happen? You might wonder. Well, it might happen because neither the receiver of the first subscription could process the message, or the second, or the third, or maybe we have by mistake create a circular reference, so the one subscription sends the message to the other, and also there is a max delivery count. So we may have 100 subscriptions, but the sender wants the message to be processed by only 10. So in this case, if the max delivery count has been exceeded, then the message is moved to the dead letter queue. Last but not least, as time is pressing, I will go through some pitfalls that you need to avoid. Earlier in my slide where I showed you how you can use Service Bus in your architecture, I mentioned that you can use logic apps to send messages to a Service Bus. This is true, but you also need to know that there are limits on how many messages you can send to the Service Bus under 60 seconds. And this limit is not a very big one. If I don't remember wrong, it's 1,000 messages, and for many scenarios this will be enough. But for other scenarios, this will really be a deal breaker. So to get over that, what I would do is that I would not use a logic app. I would use an Azure function, which has no such limit to send the messages. Then we also have the issue that the messages have a certain size, and we can only put text inside of them. So if we need to send media like pictures or videos or sound, one solution is to convert them to base64 strings, but you know that this can be really, really big, so you cannot cheat in that way. And if you do have to send a picture or some other kind of media, then upload it in the storage, in Azure Storage, get the link of that file and send that as a message. Then if you need low latency, latency is the word that I was looking for earlier. You have to use the premium tier because it is that tier which guarantees low latency. In the standard tier, and of course the basic also, may have slight delays between reception of a message and delivery to the receivers, and those, of course, those delays are like it's a matter of seconds. It's not like they will die for hours. But if you do need low latency, then you have to go for the premium tier. A big issue for me as a developer is that there is no emulator. I cannot play with a service bus in my local machine. I have to create one in Azure, and I have to use that one while developing my application. For me, this is an issue, and I have raised it with a few people working for the working with the service bus on Microsoft. And what they said is that it's not easy for them to create an emulator because all the tiers are built in completely different technologies. The basic, the standard, and the premium tier are totally different applications. So it's not easy for them to create one application that implements all the tiers. And then, of course, the service bus put in the middle of your application does not mean that your application is now completely secure. You did have a single point of failure before, which was every part of the chain. And using a service bus means that you do have one single point of failure again, but this time it is a service bus. Now, again, the service bus does guarantee high performance and fast deliveries and everything, but you need to have a plan B in case we have an outage, in case there are any problems on that specific region. And in the premium tier, we do have zero redundancy, so that even the messages are saved and everything is up and running again very, very fast. But yeah, it is one thing that we have to take into account. And the last thing that I want to tell you is that in the demo before, what I showed you, and I will just show that again very, very fast, was not what I hope that you will do. And again, let's go back to my namespace and then to my topic. If you remember, I took the connection string using the shared access policy. And this is not a good idea. I shouldn't have done that because this is a connection string, it is text. I can accidentally commit it in my repository, which then can be deprecated and or compromised, and I can have bad people sending messages to my service bus, and I really do not want that. So instead of doing that, use the access control, the IAM, and use access and role assignments. So if I want my Azure functions to be able to send messages, then I would do the least privilege rule, like the sender. As an example, I would pick that one, that role, and I would, I'm not sure if my function has, yeah, I don't, but if I had created an identity for my function, then it would appear here, and I would choose to give this role to my function. In that way, I wouldn't have to use the shared access signature. And that was those were my last words. So thanks a million for being here in my session. If you scan this QR code, you can get to my website where you can find contact information to me. And I am very, very happy to get any questions.
Thank you, Nikos, for the presentation on messaging and Azure Service Bus. It was interesting. You dived into the details of so how to configure the service, the brokers and the message pickup. I will just add from security perspective, because that's something I also have big interest, especially on Azure, is that to say that whenever you have possibility to use managed identities and connect your services using the managed identities instead of connection strings or keys, pair of keys, always try to lean toward managed identities, especially if it is for the production and staging and that environment, because that would eliminate one simple mistake where keys are shared or it is compromised, and then you end up with those data breach related stories in the news, right?
Yeah, that's very correct. Exactly. That was the last part that I saw, that you should never use the shared access policies. Instead, you should use the passwordless ways of
Yes.
connecting resources together. Yeah.
And another question, from while listening your great session on message-based, solutions is, as
Mhm.
you mentioned, Azure Service Bus. It comes with, a multitude of great options, right? It's kind of like big solution or big, I would say big solution, but let's say it has a lot of features for enterprise ready or enterprise demanding applications, right? And of
Yeah.
course, based on your use cases, you may not always need to have that one for your application, right? You don't want to catch a bird with a big gun and kind of blow everything, right? So you want to measure your solution to the use case that your customer is actually going through. So if there is
Mhm.
much simpler solutions, if you kind of give a little bit insights in terms of, okay, when it's good idea to use Azure Service Bus, when you shouldn't be using Azure Service Bus. And also, as everybody knows, Azure Service Bus is a managed service of Enterprise Service Bus, which is the open source software. And just a little bit about that as well. Thank you.
Yeah, those are very correct points, Han. I do agree on all of them, and I am an advocate of doing everything as simple as possible. Often, premature optimization is a silent killer that kills projects before they even come to surface. And using resources that you don't really need only brings expenses and problems in the future. So I do absolutely agree with you on that.
Thank you. But in terms of like simple solutions where you want to decouple application, what's the simplest thing that developers can start playing with and
Yeah.
emulating? And yeah, go ahead.
You mean without including the service bus?
Yes, without including service
Yeah,
bus.
well, a common way, or the way people did it before having the service bus, is to do it indirectly, like create a file somewhere with someone else's polling, like in the directory, which one function creates a file containing some maybe some encrypted information, and
Hmm.
another function is looking in that directory, is polling on that directory, and the moment a new file appears, they open it, they decrypt it, and they do whatever is written in the file. So, like I believe in the 90s, many people did that,
Yeah.
maybe even later. And it is like it is the cheapest way to decouple two applications, in my opinion.
Okay, great. Yeah,
Yeah.
thank you. And if there's any questions from the studio, from the people who watch, so we had like good participation, around 20 or so people from time to time were watching, and I was trying to bring any questions that they have, and I put them in the
Mm,
chat. But if I missed anyone, because when I look at the chat, I see we answered the question from Anand. So if there's any other
mm,
questions, we are coming to the end of the session. So this is the moment, guys. So you can put your question there, get answered by
yeah.
Nikos. But if they forget their question, or let's say they are working, right? Because in some parts of the world it's still a work day, and
Yeah,
they
I
come up
get
with a
it.
question later on where they should come to connect with you and ask those
Uh,
questions.
Absolutely. Where I am on Twitter under the handle ND, like the first letters of my name and surname, Technique, which is Technique in Swedish. And I am on LinkedIn with my name, Nikos Telis. And I can also be reached by email. And all this information is available on my website under the contact page, which you can get by scanning this QR code.
Great, thank you. Thank you for clarifying that and directing the ways how the people can get connected with you and get help. Or if they have any questions, clarify that. All right. Thank
Absolutely.
you again very much, Nikos. That was again very good. I would say more of a developer focused session where you dived
Mm.
into those details and showed the repo. And those code that you shared and show, is it also maybe accessible somewhere if somebody
Uh,
wants to check
I
them?
I will make it. I will make it accessible. I will upload it in the repository and send it to you.
Okay, and we have the thank you message from Anand to Nikos.
Thank you,
Thank you,
Anand. Thanks a
thank you,
lot. That's
and
very kind of you.
thank you very much as well. And uh, is let me see if there's any other things here. I don't see any, but again, we are at the end of the session. Thank you everyone for joining. Thank you our guest speaker Nikos Delis
Thanks a lot,
presenting
everybody.
on Azure Service Bus and messaging solutions and architecture that you want to consider for your solutions if you are planning to do one. And I would say, take a look at the next cloud launch and learn sessions. We have them weekly, as Nikos mentioned, and we have another interesting session coming next, which is going to about how you can get up to speed with your cybersecurity or CS 900, which is basically security fundamentals on Azure. It's
Mhm.
going to be presented by Jackson. And, till our next session, bye everyone, and thank you, Nikos.
Goodbye, everyone. Wherever you are, have a great day.
Have a great day, guys. Bye.